In this lecture, we will start talking about the operating system structure. We will go over different approaches to organize an operating system, and then we'll talk about the concept of virtual machine and how to deal with different processes. So let's start with the structure of an operating system. More importantly, why do we need it in the first place? So what is the motivation to have a structure when we design an operating system? Well, the answer to that is the services, the number of services that are managed by the operating system. So, in the previous lecture, we saw that the operating system had a lot of services that it had to manage so that different users or different users' processes can share all the hardware. So, for example, the kinds of services that are managed by the operating system include program execution, input output operation, communication between processes, resource allocation, protection and security, error detection, accounting. So there are a number of services that the operating system needs to manage, and apart from that, it needs a way to interface with the system. Note that the operating system sits between the users, and so there's the operating system, and at the other end you have the hardware. So it needs to be able to interface between the system as well. Now, what is that going to the consequence of managing so many services is going to result in a general purpose operating system such as a Windows operating system to be very, very large. So we definitely need ways to be able to structure it. So we'll quick have a brief discussion on various types of structures. The early designs were monolithic, meaning they were very simple structures, meaning there was no structure at all. And then later on, there were ideas to organize interfaces between the operating system services. So, by having interfaces between services, we can get some sort of a structure or organization that will help us design the operating system better. So, the first such approach to have interfaces was layered structure, and we'll talk more about the layered structure in just a bit. This is an operating system structure in which various services are organized in a hierarchical layer format. And there are other more modern approaches, such as the microkernel approach, in which the kernel is made very, very small, hence the term microkernel, and most of the services are moved to the user space. There's also a modular structure in which each of the services are a separate module, and there are some similarities between a modular structure and a layered structure. However, there are also some differences. There is a hierarchy, strict hierarchy built into the layered structure, which is not very strict in the modular structure. And of course, we can have hybrid structures which borrow certain good aspects of various other types of structures. Let's go a little bit deeper into the layered operating system. So, as it was established a little bit early that the operating systems are large and tend to be very complex, we need a very good way or a strategy to be able to build them. And one such idea is to be able to build them in layers. And as you can see, we have different layers. Say layer 0 is the hardware, and layer n is the user interface. And we are going to have multiple layers from layer 0 all the way to layer n, the bottommost layer being the hardware and the topmost layer being for the user interface. And the benefit of having such a layered approach is that there are very clear interfaces between each layer. So if there was something to go wrong in one layer, we would know where to look for that error. So we can isolate errors by having this very clear distinction of the interfaces between layers. And each layer, what does it do? It provides us services. And by having such a layered approach, say for example, any layer can use the services provided by all the layers below it. So that has a disadvantage, and we'll talk about that in just a minute. So the idea is to build them in layers. This is somewhat of a modular approach because we are uh, modularizing services per layer. However, it's not a very strict modular approach because there is a hierarchy built into place. It is portable, which means that I can take these layered approach operating system structure and port it to a different hardware, and it would still be able to work because I have isolated them. Each service I've isolated them into layers. Um, and then the basic idea for a layered operating system structure is to be able to divide and conquer. So each layer is simple, but because they have been built on top of each other, we can tackle a complex task of as complex as the operating system. And let's talk about the layered approach and some consequences. So the higher layers are written in terms of the lower layers. This means that any layer above, say layer 2 will use the services of layer 1 and layer 0. But layer 2 will not be able to use the services of layer 3 and so on. So layers use the services of layers underneath. So I should say layers, a service at a particular layer uses the services of the layer underneath it. The lower layers can hide details from the higher layers. What that means is a particular layer cannot use, is prohibited to use the services of a layer above it. So that's essentially a problem. So the problem over here is that a service cannot use a service provided by a layer above it. So essentially that's the disadvantage, but some advantages do exist with a layered approach. The fact that there are clear interfaces, and the fact that for a development purpose, when we would need to isolate error to a particular layer, it would be easy to do in such an approach. Okay, so now let's see. We were talking about user processes, and the fact that there's a distinction between user space and kernel space. The user space is not a privileged mode. So, how do the various services provided by the operating system fit into this structure where we have a user space and kernel space? So, in this particular diagram, we have users way at the top, which are part of the user space, and all the way at the bottom here we have the hardware, and in the middle we have so users will use shells in which they write commands, and we use compilers to be able to go down this list and access the resources of the hardware. But the users, as well as the shells and commands and all those aspects of user processes, fall in the category of user space. Underneath that we have the kernel space, and kernel space is further divided into two layers. The first layer being accessible by the system call interface to the kernel. So for example, if a user process needs the service of the needs the service that is belonging to the kernel space, it would essentially request the operating system using a system call to work on its behalf. And we looked at that using the mode bit approach in the previous lecture. So some of the services provided in this highlighted region of the kernel include the I/O operations, file system support, scheduling the CPU, and the implementation of virtual memory. And underneath that, using the device driver interface, we are now getting more and more closer to the hardware. Over here we have the device controllers or the I/O controllers, and they could include memory controllers, controllers for disks and tapes, or they could be terminal I/O controllers. And underneath that, of course, we have the shared hardware. So on the top, users that are operating in the user space, and then the kernel space being divided into two layers. One is software, and the other is sort of the device controller, so it's very close to the hardware layer. Okay, so in the next lecture we will start talking about the virtual machine.